Hey, hello everybody. I'm going to do a few videos reviewing for our semester one exam. This one is a review of the different kind of limits that we've been working with during the first semester. Limits being one of the big themes from this term. If you want a copy of this document, you can find it right here on the calendar under Limits Review Activity. Away we go. There are 7 different functions here where we want to talk about sort of the end behavior limits. And I want to organize them into groups. So the first group would be A and B. These are the same kinds of functions. Notice that these are all x to the power. That means that these are polynomials. Translation, these are what we talked about in Unit 3. So let's talk about those first. With a polynomial, there's two things that you want to identify to determine the end behavior. The first thing you want to identify is what we call the leading coefficient. So the leading coefficient in the case of A would be that the term with the largest degree, that's this one right here. Boy, you really can't see that very well, can you? Let's see if we can make that a little darker. Okay, improvement. This is a negative x to the fourth power. So that has the largest degree. That means that -1 is our leading coefficient. Meanwhile, if you looked at B right here, the largest degree is the 3. So that means that our leading coefficient would be -4. Either way, see how they're both negative? That tells you that the right side of both of these graphs is going to be approaching negative infinity. So both for A and for B, we can say that the limit as x goes to infinity is negative infinity. The left side limit, which we're trying to identify here, is determined by the degree of the polynomial. Now notice that these are in standard form, and that means if you want the degree, all you need to do is look at the largest exponent. So here our degree would be equal to, degree we usually use an n, is 4. And here our degree would be 3. If you have an even degree, that means that the right side and the left side are going to go in the same direction. So for A of x, the left side limit is also going to be negative infinity. For B of x, the degree is odd. If you have an odd degree, that means that the left and the right side are going to move in opposite directions. So the left side is going to be going up, and so the limit as x goes to negative infinity for B of x will be infinity. By the way, I guess I never changed these. See how these are all g of x? They should be A of x, B of x, C of x, and so on. Anyway, moving along, we come to the next 3. The next 3 you'll notice are all fractions. And so these are what we call rational functions. A rational function is anything where you have a polynomial in the numerator and the denominator. This is what we talked about in Unit 4. Now, the way you identify the end behavior limits for a polynomial, totally different. So, for instance, for this guy, what you want to look at is the degree in the numerator and the denominator. So C of x, we can see this one is bigger on the bottom, right? We have a degree of 1 there versus a degree of 0 on top. D of x, it has the same degree in the numerator and the denominator. And then E of x, it has a bigger degree in the numerator. Okay, so what does that tell us? For C of x, since the degree is bigger on the bottom, that tells us that there is going to be an end behavior asymptote at y equals 0. For E of x, because the degree is bigger on top by 1, right? The degree up here is 2, the degree down here is 1. That tells us that we're going to have a slanting asymptote. For D of x, since the degrees are the same on the top, the only thing that really matters is these two coefficients right here, which would give us 8 over 3. So this one is going to have an end behavior asymptote of y equals 8/3. All right, so what does that tell us? That tells us that for c of x, both the left and the right side will be approaching 0. So both of these limits are 0. For d of x, both the right and the left side. By the way, I'm not trying to draw the whole graph, so I'm not really concerned with whether this part right here is above the end behavior asymptote or down here below the end behavior asymptote. That's not important. What we know is that on both sides, that's the number that this fraction is going to get close to. So both of these will be 8/3. For the last one right here, since this is a positive number, you know that over here it's going to be going up to positive infinity, and then over here down to negative infinity. So left side negative infinity, right side positive infinity. Moving along, the last two right here are our exponentials and logs. Okay, so specifically, we have an exponential right here. We have a log right here. Let's go. For the first one, this is an exponential, and for an exponential, the asymptote is going to be determined by the shift up and down. So this 3 right here tells us that there will be an asymptote at y equals 3. Whereas for the log function, we know that the asymptote is going to be vertical, and that means that it is controlled by the horizontal shift. So this +8 tells us that we're going to have an end behavior asymptote at y is equal to -8. All right. From there, let's do the exponential first. See that our base is e to the -1, which is 1 over e. And that is smaller than 1. And that tells us that this thing is going to decay. So our graph will look something like that. And now that we know that our graph is decaying, we can say that the left side's going to infinity and the right side is approaching 3. In the case of the log, unless there's a negative in front, you know that it's going to be increasing. So for this one, I'll do the right side limit first. As x goes to infinity, y is also going to infinity. On the right side, as x is... Oop, I made a boo-boo right here. That should say x is equal to -8. As x is getting close to -8 and doing so from the right side, y is dropping. So y is approaching negative infinity.